So let me start section 1.3. And so section 1.3 talks about, well, different techniques on collecting data. And so let me go through those different techniques. And so, the different techniques are the following that we'll be going over. And well, these are popular techniques. And so let me go just sort of give you the names of these techniques, and then we'll go over each of these. So a convenience sample, voluntary response sample, random sample, simple random sample, systematic sample, a stratified sample, a cluster sample, and then these multi-stage sequence samples. Okay, so, I guess I'll say that first. The reasons for sampling are, it saves money. It saves both time and money. Next, it enables the researcher to get information, to get more information. And so it enables the researcher to get information that he or she might not be able to obtain otherwise. It enables a researcher to get more detailed information about a particular subject. So, a convenience sample. A convenience sample is one where it is easy to obtain the data. And so that's a convenience sample. A voluntary response sample is a sample in which the participants volunteer to be in the sample. Such as when you have a dial-in poll from, say, some news program, and they ask you to dial in and vote for a particular issue. So, a random sample is one of the more important techniques. So a random sample is a sample in which every member of the population has an equal chance of being selected. And so the members from the population are selected in such a way that each member in the population has an equally likely chance of being selected to be in the sample. So a disadvantage of a random sample is that if your population is large, then it might be time consuming to number and select your members to be in your random sample. So a simple random sample of size n. So a simple random sample is denoted by SRS. So a simple random sample of size n is a sample of n subjects in which every possible sample of the population of the same sample size n is equally likely to be selected. And so a simple random sample of size n is such that every sample of size n is equally likely to be chosen from the population. So there are two differing ways to select a simple random sample. And so one way is with, the other is without replacement. So a simple random sample with replacement is denoted by SRSWR. The simple random sample without replacement is SRSWOR. So if you see those abbreviations, you know that they're, well, simple random sample with replacement or a simple random sample without replacement. So a simple random sample with replacement of size n is a simple random sample of size n, where after each selection, the member in the sample can be selected yet again. So let's say that you are selecting balls from a bag. So you select a ball from a bag and you notice what color it is. Then you throw the ball back in the bag. And then you shake it up and you select another ball. And you keep noting the color of the balls. And maybe you want a simple random sample of size 12. So you'll select 12 balls in that fashion. So this would be a simple random sample with replacement. So you keep replacing the balls back into the bag. And so you have a simple random sample with replacement. We can also do a simple random sample without replacement. And so a simple random sample where each member can be at most one sample is called a simple random sample without replacement. So to determine a simple random sample without replacement, what we do is we select, well, so let's think of this example. Suppose I want to select members of some students to be in some sample. So, and let's say the sample size is 5. So say I want a simple random sample without replacement of size 5. So what I'll do is I will randomly select one student, have them come to the front of the class, randomly select another student, have them come to the front of the class, until I have a total of 5 students. That will be a simple random sample without replacement. You notice that as I select students to be in the sample, the number of possibilities of students that I can put into the sample keeps getting smaller and smaller because I keep taking out one additional student each time I select it. And so a simple random sample with replacement acts as if the population is infinite because I keep putting the student back, I select them, and then I have the student sit back down. Which acts like the same as if I took students out and did it with replacement, without replacement, but the population was infinite. So it never sort of reduced how many students there were to select from. So basically a simple random sample with replacement makes the population look infinite. Whereas if I have a simple random sample without replacement, it will keep reducing the number of members that I can select from the population each time I select one additional member to be in the sample. So unless otherwise stated in this course, I will assume that every sample will be a simple random sample without replacement. So let's do some examples. Let me use my TI-83. So let me start up my TI-83. Okay, so here it is. So let me do this. Wait 1 second. Just check something. Okay, good. So let's say I want to pick a random number, a random integer between 1 and 20. And so to do that, I would click on Math, then use these arrow keys here to go over to the PRB menu. Once I'm at the PRB menu, I can choose the random integer. It's the 5th one down. I can either choose it by going there with the key arrows and hitting enter, or just clicking on 5 because it's the 5th one down. I could put in 1, comma, 20. I should, but I don't need to. Close my parentheses. So one number between 1 and 20 is, well, 2. Say I want to pick 5 numbers between 1 and 20. I could do, let's see, go over, click on Math, go over to PRB, pick the 5th number, 5th choice down, do 1, comma, 20, comma, 5. So I am in parentheses. So I'm picking 5 numbers between 1 and 20. And so here are 5 numbers between 1 and 20. But notice, I did it twice. Notice that when I do this, I could have the same number picked twice. So this is a simple random sample with replacement. And so this is a simple random sample with replacement. If you want to do, if you go to the very bottom of this and you do a random number without replacement. Oh, I hope I know how to do this. 125. Hopefully this works. No. No. Okay, so here, wait 1 second. I don't remember how to do it. Okay, wait. Oh, 1 second. Let me check something. I want TI-83. Oh, here it is. Oh, you have to put it there. Let me just check something. Okay. Sorry about this. I don't remember. You do have to put it into. Okay, so it's a list. Okay, let me just check. You have to put it in there. Okay. I believe. So that's what it's. I think you have to store it in something. No. Okay. Oh, maybe. Okay, I'm gonna forget this. Evidently, I don't remember how to do it.
Professor, I have a question.
Yes, question.
So because you said that previously that sample is a portion of the population,
Yes.
but in this case, we're studying that the different type of sampling, but that doesn't mean that you need to gather all the data from the whole population in order for you to take the sample of the population. You can just grab, let's say,
Yeah, so that's why we're taking a sample, because we're not doing it from everyone in the population.
but when analyzing, you still consider the whole population in order for you to get like percentage and stuff like that, right?
Well, the sample is taken from the population. So you will randomly select members of your population to be in your sample. Okay. So evidently I don't remember that. Okay, so let me go on. Let's do it with Excel. I know how to do it with Excel. Let's do Excel. So Excel. Where's my Excel? Okay, here, wait. Let me do Mathematica first, and I'll do Excel, because I don't see Excel here. Oh, no Excel is here. Okay, there's Excel. Okay, so do that. So suppose I want a random number between bottom number is 1, top number is 20. So that gives me one number between 1 and 20. And suppose I want 5 numbers between 1 and 20. And then that's 5 numbers between 1 and 20. Oh, you would take this box here. Once it becomes this like solid plus sign, you just grab a hold of the corner and drag down. And that gives you the same command repeated over and over again with the appropriate changes. Okay. So there's 5 numbers. And of course, you notice that they could be the same number repeated. Okay, Mathematica. Let's do Mathematica. So I would just type in a random integer. Let's go from 1 to 20. So a random number between 1 and 20, 4. If I wanted to do, let's say, 5 numbers between 1 and 20, I'll just say comma 5. That'll give me 5 numbers between 1 and 20, but that is a simple random sample with replacement. If you want to do a simple random sample without replacement, you can do a random sample. And let's do from some collection of numbers, let's say 1 to 20. Actually, let me just say 20. So that's from 1 to 20. And I'll pick 5 objects from that. And notice that, let's pick 20 objects, just so that you're convinced. None of them ever repeat. So this is without replacement. And so I pick 5 numbers randomly between 1 and 20 without replacement. R. Let's do R. So let's do one number between 1 and 20. 10. Let's do 5 numbers between 1 and 20. And so sample 1 to 20, comma 5. Okay, good. Let me check. Let's see if I can. What is that called? Let's see if they have random. They have a normal. No, they don't. Okay, sorry, I was looking here. See if I can do it with stack disk. Sort. Normal. Uniform binomial. No, they don't. Okay, so can't do it on that. Okay, so let's go back. There is 1.3. Okay, so they gave you several random samples using several different types of technology. Systematic sampling. So in systematic sampling, you arbitrarily start at some point, and then you pick every, whatever, let's say every third member. So you pick every third member, and that will be your sampling. So you select some starting point, then select every kth element in the population. So you number your population, and then after you have selected your first element, you select every kth number after that. So this is similar to, well, the Roman method of instilling loyalty to their ranks, which is called decimation. A deci is 10. And so what the Romans would do is after they conquered a particular region, they would then enlist their male population, the adult males, to be in their army, to the Roman army, to ensure the Pax Romana, the peace, Roman peace. And they would, to ensure that these new conscripts would fight for them and not run away or not sort of fight against the Romans. If anyone, let's say, abandoned the fight, they would then arbitrarily, they would line up everyone, arbitrarily pick a starting point, and then have every 10th person step out of the line, and they would then have them executed. And so that would ensure loyalty. Oops. Let's see. Oh, that's not moving. I got disconnected for a second. I'll get back. So, advantage of systematic sampling is that it's easy to select sample elements, but it may be biased if they I'm coming back online. Okay, good. I'm now back. So the advantage of systematic sampling is that it's easy to select sample elements. So things like in exit polling, they actually pick every 10th person that is voted to ask them. So it's easy, just pick the 10th person. Disadvantages is that it may produce a biased sample if the population is listed in a structured manner. So let's say that you do male, female is the way that you've ordered everything, listed everything, and you pick every 10th person. Well, and the first person you pick is a male, then everyone in the population is going to be in your sample will be male. So that's obviously biased. Stratified sampling. So in stratified sampling, you will determine what are called strata. And these strata are such that every person in the strata, every member of the strata, is as homogeneous as possible, according to some characteristic. So every person in this particular strata looks identical in that particular characteristic that you're looking at. And so, you will subdivide the population into differing subgroups that share some characteristic. And then you will draw a sample from each of these subgroups, from each of these strata. And so you subdivide the population into strata. Each stratum will be as homogeneous as possible in relation to some characteristic that is important for you to study. Then you will select members from each of the strata. And so just remember, the strata are homogeneous, are homogeneous in a particular characteristic or characteristics relative to the population. So the advantage of stratified sampling is that it ensures representation of all groups in the population that are important to the study. So you have subdivided your population into all of these strata. Disadvantage, this is impossible almost. If there's a large number of variations of interest, the task of dividing a large population into representative subgroups requires a great deal of effort. If the variables are somewhat complex or ambiguous, such as beliefs, attitudes, prejudices, it is difficult to separate individuals into subgroups according to these variables. It is very difficult to stratify a population. So polling organizations, especially political polling organizations, are very expensive because of the difficulty of stratifying a population. So this is why these political polling that are attached to your campaign are very expensive, is because of the expense and difficulty of determining your strata. A cluster sampling. So in a cluster sampling, you have these clusters that are as heterogeneous as the population. So you hope that these, let's say, precincts, look like a microcosm of the whole state, or maybe the whole the whole country that you're looking at. So here you will divide a population area into sections called clusters. Then you randomly select some of these clusters, and you choose several members, most members, from these clusters. And so you then subsample in the clusters. I would choose a representative sample. There. So now you choose a representative sample from members of the selected clusters. These clusters are as heterogeneous as the population. So they should be a miniature version of the population. A cluster sample is a sample obtained by selecting a pre-existing natural grouping called a cluster. So, advantage of cluster sampling is that a cluster sample can reduce costs because it's a pre-existing grouping. It can simplify fieldwork, and it is convenient. Disadvantage is that even though they're supposed to be as heterogeneous as the population, they never are really as heterogeneous as the population. So elements in a cluster may not have the same variation in characteristics as elements selected from the population. So it used to be that, especially in the 1950s, whenever they were doing any sort of thing involving politics about a race, some sort of political race, they would go to Peoria, I think that's Illinois, Peoria, Illinois, and they would ask people in Peoria what their feeling were about a particular candidate, about particular issues, because in the 50s they looked relatively like the United States, but actually they were what they did not represent were minorities. So they were essentially white males. They had a lot of elderly white residents. They're much less representative now. Now they don't ask people in Peoria what they think, because they're in the 50s. They were at least somewhat characteristic, as heterogeneous as the United States, but they're no longer. So in a multi-stage sampling, you will be using several techniques to collect your data. So an example is, let's say, a pollster will select a sample in different stages, and at each stage they use a differing technique of sampling. So in exit polls, strata are first determined, then clusters are determined from the strata. These are called key precincts. So these key precincts are determined. And then once you've determined these key precincts, participants, meaning voters who have already voted, are chosen by systematic sampling. I believe they choose every 10th person exiting the polling location, and they ask every 10th person how they voted. Sequence sampling is usually done with quality control. So say you have some conveyor belt, and so successive units are sampled. So say you have a production line, and you're sampling successive units so that you can be sure that they meet certain standards set by the manufacturing company. So double sampling. So in double sampling, you first give, let's say, a questionnaire to determine who meets the qualifications for the study. And then after you've figured out who qualifies, then you pick a sample from those who qualify. And so that's called double sampling. And multi-stage sampling, the exit polling was an example of multi-stage sampling, where you keep, in each stage, you use a differing sampling technique. Okay, so that really finishes off section 1.3